Hello everyone, welcome to my channel. So today we're going to talk about what is the difference between a strong and a concentrated solution and a weak and a diluted solution. So let's get into the topic quickly. So now I would be first explaining you what is a strong and weak acid or bases. So first I would be taking acid and then I would be explaining bases. So now when we talk about strong acid, just like HCl, okay, so this HCl which is there, it would go under dissociation. And what does dissociation means? Dissociation is nothing but separation to form ions. Okay, so this would be what would be happening to the HCl molecule when it's in the aqueous form. So always remember, all the acids which are there, they only show their acidic properties only in the aqueous solution or in liquid state. Okay, so the HCl which is here, this would dissociate to form H plus and Cl minus ion. And when I talk, so this here is a strong acid. Now I would be talking about a weak acid. The weak acid would be CH3 COOH. That is nothing but ethanoic acid. Or you could also say this as vinegar. Okay, so when you talk about dissociation of a weak acid, I would be putting this sign here. I would be explaining you what this sign is about. So this sign here, it indicates that the reaction is going in the forward as well as the backward direction at the same time. It means what? When the reaction would be happening, so this vinegar which is there, it be dissociating into ions, that is forming this ion and the H plus ion, and again it could go backward, that is it would be again forming a molecule which is there. Whereas in the case of HCl, what do you see? It would be just going forward. Okay, so now what we see, that because of HCl just going in forward direction, it produces more H plus ions. Okay, and when you talk about this, it produces less H plus ions because it's going in the forward and backward. So what happens, that the overall concentration of H plus ions basically remains less as compared to the strong ones. Okay, so we could say that all acids which are strong, they fully dissociate, as in they fully dissociate or separate to give the more amount of H plus ions, and here I could say they partially dissociate. Okay, so that's how the strong or a weak acid is defined. And so if they ask you what is a strong acid, strong acids are those acids which dissociate fully, so they have more concentration of H plus ions, and vice versa for the weak acid. So when I talk about any acid, like for whenever I talk about an acid who has more amount of H plus ion has lesser pH and are more acidic. Okay, so the acidity of any acid depends upon the concentration of H plus ions. For now, we just consider its H plus ions for you. So we just understand that whatever acidity which is coming to an acid, it's because of the H plus ions. So here, since there is more amount of H plus ions released, therefore there would be more acidity, therefore less pH. And when there is less amount of H plus ions release, therefore it would be less acidic, therefore the pH would be more. Okay, so the pH and H plus ions goes into inverse relationship. So if your H plus ions are more, then your pH would be less, and if your pH is less, then your H plus ions. So they go into this relationship. So therefore I hope this concept was clear to you, that what is the difference between a strong and a weak acid. A strong acid, they dissociate partially. A strong acid dissociate completely and therefore more H plus ions, so less pH. And when you talk about a weak acid, they dissociate partially, therefore they have less H plus ions and therefore the pH is more and they are less acidic. So now we would be talking about bases. So bases would be also the same case. Here, when I talk about a weak base, they would be dissociating less, and when I talk about a strong base, they would be dissociating more. So I would just show you that quickly. So this here is an example of NaOH, which is a strong base. So again, when I talk about a strong base, it would dissociate completely into NaO plus and OH minus ions. But when I talk about a weak base like NH4OH, let's write it here, a weak base, and it would dissociate again into NH4 and OH minus ions. So what do you see that this here, it's just going in the forward. So they would be having more OH minus ions. Therefore, the dissociation is more. Whenever you have OH ions present, okay, so the pH is directly proportional to the OH. So if your OH ions are more, then your pH would be more. Okay, so the ones which have more OH ions, they would be having more pH, and therefore they would be more basic in nature. But when I talk about an weak base, okay, so since because of the partial dissociation, they will be having lesser amount of OH minus ions, therefore less OH, and therefore less the pH. So whenever when you talk about a strong acid or a weak acid, you're basically talking about that degree of dissociation, as in how much it could give ions of H plus or OH or whatever it is. So whenever we are talking about a strong base or a weak base, we are talking about degree of dissociation, that how much a specific base or an acid could dissociate. So this was based on what is a strong base and an acid. So now you'd be talking about what are concentrated acid and concentrated base. So when I talk about a concentrated solution, so first I would be taking an example of sugar. So consider I have taken 2 beakers. So in one beaker, I would be taking equal amount of water in both of them. Okay. So I would be taking 100 ml of water in both of them. And what I would be doing is that in this beaker, the beaker A and beaker B, there are 2 beakers. So in the beaker A, I would be putting 15 grams of NaCl, and in this I would be placing 2 grams of NaCl. Okay, so now when you talk about this, then the beaker A would be also surely called as concentrated because it has more amount of the salt which I have kept. So the A1 would be called as concentrated and the B1 would be called as dilute. So same happens with when you talk about the solutions. So when I talk about a concentrated strong acid, so what I mean to say is basically that I have kept in the beaker, the acid which is there, it's strong. It means it has the property of dissociating fully. So it has property of dissociating fully, and second thing is that I have taken more amount of acid, as in, like for example, if I take so the total solution is 10 ml, okay, and in that I have added 8 ml of HCl and 2 ml of water. So it would be called as a concentrated solution of a strong acid. Okay, when I would be saying that if I using a dilute solution of a strong acid, it simply means that instead of taking 8 ml, I would be taking like 2 ml of HCl and 8 ml of water. So that's what the difference between a concentrated strong acid is and concentrated and dilute weak acid is. So now, so instead of taking a strong acid, if I take a weak acid, so a weak acid could also have 2 solutions. for one is concentrated and one is diluted. Okay, so when I talk about the weak acid, the weak acid are those which dissociate partially. So when I talk about weak or strong acids, I'm talking about the property of acid, and when I talk about concentrated or dilute, I would be talking about how much water is added to it. Okay, so same goes for this. So when I talk about a weak concentrated acid, it means I have taken in 10 ml of solution, I have taken 8 mLs of CH3CO, that is your weak acid, and 2 mLs of water. And when I talk about a diluted acid, I would be if it's of 10 ml, then 2 mLs of CH3COH and 8 mLs of water. So that's what the difference is. So when anyone would be saying, okay, this is a weak acid, they are basically telling their properties of the acid, that about the dissociation. And when they talk about the concentration, they would be talking about at how much water is added to it. Okay, so now of course the pH of both of them, so the pH of strong acid and weak acid would be different, and pH of the concentrated and dilute would be different, because as we know that the pH depends upon the H plus ions and the OH minus ions. Consider if we are taking a concentrated weak acid, so the pH of the concentrated acid would be less as compared to the pH of a dilute acid, because simply we know that we follow the relation that pH is inversely proportional to H plus ions. So whenever you have more amount of H plus ions, so here since it's concentrated, it would be having more of this acid, and since more of this acid, therefore it would be having more H plus ions, and in this case it would be having less. So we are just comparing both of them. We are not comparing with an HCl. Of course, the HCl would be having lesser pH as compared to this acid which you are talking about, that is ethanoic acid. So of course, always remember that that concentration and dilute also changes the pH. So if the solution is very dilute, then it would be going towards neutral solutions. Consider if I take in 10 ml of a solution, out that I would be taking 2 ml of H2O and 8 ml of HCl. Okay, so now what I do is that to this solution of water and HCl, I keep on adding more amount of water. So of course this would be having a very low pH, because it would have a very high concentration of H plus ions. So as I would be adding more and more water to it, the pH would slightly go from, so the pH scale for acidic solution is from 0 to 7, and for bases would be 7 to 14. Okay, so now consider if my pH of this acid is around like this, like around 0.5. So when I'm adding water, slowly and gradually it would go to 4, then it would go to 5, and finally it would turn to a neutral solution if I add a very high amount of water to it. So consider in 8, so here it's 8 ml. So if I add 1 liter of H2O to 8 ml of HCl, then it would be slightly acidic, but it would be more towards neutral. So that's what the difference between a strong and a weak acid. So that's what the difference between and. So now consider, instead of taking an acid, I am taking your base. So in 10 ml of solution, I would be adding 2 ml of NaOH and 8 ml of water. So of course this, since it's a strong acid, it would be having a certain pH around 12 to 13. It won't be having like 14, because since we have taken slightly dilute. Okay, so now as I would be adding more water to the solution, slowly and gradually it will go to 7 and it would become neutral. So consider in this solution, if I take 2 liters of water into the solution of NaOH, and slowly and gradually the solution would become neutral, like if you add a very high amount of water. And that's what when I was talking about a concentrated and a dilute acid, and when I talk about a strong and a weak base, I would be talking on the basis of their dissociation properties. So I hope this video was helpful for you to understand the difference between a strong and a concentrated solution and a weak and a dilute solution. So if you like my videos, please press the like button and subscribe.